Welcome to part 2 of the Calculating the Abundance of Isotopes Using Algebra lesson. If you haven't already watched part 1, go back and do that before you go any further, because in that video I'll show you how to actually do the calculations. In this video, it's your turn to have a go by yourself. The learning outcome for this lesson then is to use the rules learned in the first part of the lesson to calculate the abundances of two isotopes of an element. The way we'll do this is I'll give you two practice questions. The first one, if you get stuck at any point, you can restart the video and I'll give you a little bit of guidance about what to do next. The second one, I'm going to leave you to do it completely by yourself. For each question as well, I'll ask you to present your answer in a slightly different way so that you can get the opportunity to see different types of examples that might come up in the exam. Here's our first practice question then. Chlorine has two isotopes, chlorine 35 and chlorine 37. The relative atomic mass of chlorine is 35.5. I'd like you to calculate the percentage abundances of the two isotopes. So pause the video and give this a go. Remember as well those 5 pointers that you wrote down from the last video. You can use those to help you out. If you get stuck, remember, restart the video and I'll point you in the right direction. When you're ready, off you go and best of luck. How are we doing then? Have we managed to get an answer? Well, if you're struggling, start by working out your algebraic expression. Get that bit done first. Remember, you'll need to use this equation. The relative atomic mass is equal to the sum of the mass times the abundance. And remember the idea as well that the total abundance is equal to 1. With this in mind, we can say that the abundance of chlorine 35 is x, and that means the abundance of chlorine 37 is 1 minus x. If you did this the other way around and made chlorine 37x, that's fine, don't worry, it will all still work out. So now we have some abundances. We can use everything we've got and put it into that expression, and that will give us our algebraic expression that we can use to work out x. So let's see if you can have a go at that. Pause the video when you're ready, restart it, and then we'll check your answer. The expression you should have then is 35.5 equals 35x plus 37 times 1 minus x. Where that comes from is the 35 is the mass of chlorine 35, and we decided that its abundance was x, and the 37 is the mass of chlorine 37, and the 1 minus x was its abundance. We've got the expression then, so the next step is to solve for x. So you can pause the video again, give that a go, and restart when you're ready to check your answer. Have you got x? Well, let's see what you've done and see what I've done, and we'll see if we both get the same answer. This is what I would do then. So here's my expression from earlier. 35.5 equals 35x plus 37 times 1 minus x. And then the first step is to expand the brackets. So I multiplied 37 by 1 and 37 by minus x, and that left me with 35.5 equals 35x plus 37 minus 37x. What we need to do now is combine the like terms. So if I do 35x minus 37x, that leaves me with 35.5 equals minus 2x plus 37. Now I need to simplify, so I need to remove the 37 from the right hand side. To do that, I need to subtract 37, but remember what you do to one side, you have to do to the other. So I've subtracted 37 from both sides of my equation. That leaves me with minus 1.5 equals minus 2x. Almost there then. The final step is to just calculate x. I can do that by doing minus 1.5 divided by minus 2, and that works out as 0.75. So we've got x now. X is 0.75. We haven't actually answered the question though, because the question asked us to calculate the percentage abundances of the two isotopes. So we've got a little bit more work to do before we're done. Let's see if you can work out the percentage abundances then. So pause your video again and restart it when you're ready to check your answer. Hopefully you've managed to work out that the percentage abundance of chlorine 35 is 75% and the percentage abundance of chlorine 37 is 25%. Let's check the working for that. Remember the abundance for chlorine 35 was x, which worked out as 0.75. Which, bearing in mind the total abundance is 1, means that the abundance of chlorine 37 is 0.25. Once we have the decimal abundances, to get the percentages, we just need to times by 100. So 0.75 times 100 gives you 75%, and 0.25 times 100 gives you 25%. And that's it, we've answered the question fully now. Did you get the answer then in the end? If you did, well done. If not, don't worry too much about this. It takes a little bit of practice to get confident with these. You might want to then think about starting to revise your algebra from GCSE. So any errors with that, really think about whether it's worth your time to go back and do some GCSE revision. So there we are. Are you ready for the next one? Here's practice question 2. Lithium is another element with two isotopes. Its isotopes are lithium-6 and lithium-7. The relative atomic mass of lithium is 6.90. This time, I'd like you to calculate the ratio of the abundances of the two isotopes of lithium. For the most part, there's nothing new here, so I'm going to leave you to get on with this one by yourself with a little bit less help. Even though you've been asked to calculate the ratio, you're going to do exactly what you did earlier, and that's get the decimal abundances first of all. Once you've done that, you'll need to think about what you can do to present your answer as a ratio. Are you ready? So pause the video, have a go, and restart when you're ready to check your answer. Have you got something? Well, let's go over it and see if you're correct. Now you can see I've got the algebraic expression that I've worked out on the board here first of all, and where I've got that from is by deciding that lithium-6 was going to be x and lithium-7 was 1 minus x. So my expression is 6.90 equals 6x plus 7 times 1 minus x. I expand the brackets, and when I do so, that leaves me with 6.90 equals 6x plus 7 minus 7x. Then I combine the like terms, so doing 6x minus 7x gives me 6.90 equals minus x plus 7. Now I need to simplify the equation and get x. So I need to subtract 7 from both sides, and that will leave me with 0.1 is equal to x. Now we have x, but again we haven't answered the question yet, so let's see how we do that. We were asked then to calculate the ratio of the abundances of the two isotopes of lithium. So the first thing I need to do is get the decimal abundances for each isotope. Lithium-6 was x, so its decimal abundance is 0.1. Lithium-7 was 1 minus x, so its abundance is 0.9. Now when you present a ratio, you just show how much of one variable you've got compared to the other. So it'd be perfectly fine for me to give the ratio as 0.1 for lithium-6 to 0.9 for lithium-7. But it looks a bit strange giving it as a decimal there, so it makes sense to just give this as a whole number ratio instead, which is 1 to 9. And that's it, we're done. So you've seen 3 example questions, 2 on this video, 1 on the previous slide, about how to approach questions where you have just 2 isotopes of an element. What's coming up next is where we have more than 2 isotopes of an element. Now, these questions that we'll be looking at will be a little bit harder, but a lot of the same principles that we've talked about in the last 2 videos will apply to that. The only thing is we'll have a little bit more figuring out to do when it comes to the algebra. So when you're ready, start the next video and we'll learn how to approach those questions.